I wanted to clear up some confusion that you all may be having regarding observational studies versus an experiment, and tell you about some changes I made on the second quiz for section 1-4, problem number 13 in particular. Anytime there's confusion about a concept, you should always go back to the definition. So let's look at the definition that the author provided for observational studies. It says we observe and measure specific characteristics, but we don't attempt to modify the subjects being studied. And so when you look at whether or not something's an observational study, we want to know, are we trying to modify something? Are we looking for some result? Now, I consulted a couple of different sources, and I found another definition that may be a little clearer for you for the observational study. This is from Sullivan, a textbook that we've used before. It says, in an observational study, the researcher observes the behavior of the individuals in the study without trying to or expecting to influence the outcome of the study. So when we think about the example, a doctor's performing test uh, to determine the reason for a patient's illness, the question is the doctor expecting to influence the outcome of the study? Is he expecting for some change to happen because of the test that he's performing? I'm kind of jumping ahead, um, but you could consider something like a test of your blood pressure. When you go to the doctor, it's not a chemical test necessarily, but your blood pressure is taken. You could consider that a test that would help the doctor determine what the illness might be. But when your blood pressure is taken, there's no manipulation that's involved that would, we're looking for that to cause some change in the patient. Okay? So in an observational study, the researcher observes the behavior, but they're not expecting to influence the outcome of the study. Now, in an experiment, we apply some treatment and then proceed to observe its effect on the subjects. Okay, so there has to be a treatment involved, and usually we have more than one group involved because we want to know what would happen without the treatment versus what happens with it. We have to be able to account for the additional benefits given that the treatment was applied. Now, again, I consulted another source to give a better definition for this. It said in a designed experiment, which, that's an experiment, the researcher assigns individuals to a certain group, intentionally changing the value of the explanatory variable, then records the value of the response variable for each group. So we'll look at an example in just a second, but let's say we wanted to know something about the benefits of fertilizer. Okay, I might have some plants that I just plant in an enriched soil, and then I might have some that I plant in the same soil and add a fertilizer. So I've got two groups, and I've changed the variable, whether or not they received fertilizer, and I'm going to be looking to see how it affects the growth of the plant. That's an experiment. A treatment was intentionally applied so that we could determine the effect of that treatment by looking at the outcome on our response variable, okay, for each group. Now, there are several problems with this question. It said a doctor performs several diagnostic tests to determine the reason for a patient's illness. Okay, well, what kinds of tests are we talking about? I think there's some ambiguity in the word test, so we don't really know. Like I said, taking blood pressure on a patient could be a test, or you could put a person on a treadmill. That could be a test. Or you could give them one of those dye solutions, to see how they respond to that. That could be a test. I would still say, though, the doctor's not, looking to see how they respond to the particular test. He's not giving a treatment. He's really just making an observation because he's just trying to determine the patient's illness. The other thing that's missing here that would eliminate this from being an experiment, in my opinion, is the groups. Okay, we've got one patient. So where's the other group? Now, if you did your studying, we talked about a little bit about the matched pairs design. You could be your own match where we do kind of a before and an after, but that's not happening in this problem. Overall, what I would say is that this problem is confusing. Originally, what I did was I went back through the test or the quiz, that particular question, and people who answered observational study, I gave them credit for that. People who answered experiment, I took credit because I wanted you to see that it changed and ask why and make sure you're clear about it on the test. Remember that the quizzes are low stakes assessments. We'll probably have hundreds of questions. You can see most of the questions are just 1 point each. And all the quizzes, those hundreds of questions are 15% of your grade. Whereas on a test, each test is 15%, and it's only going to have maybe 20 to 30 questions. So it's more important for you to take this small penalty now and get an understanding so that when you see this on the test, you're clear about it. Now, that said, again, I think this question is very ambiguous. I've had some discussions with other instructors here about it, and we all decided it's not a good question. So what I'm going to do now is just go back and give everybody credit for the question because the question was a bad question. Now here's a better question, okay? 50 patients with lung cancer are divided into two groups. One group receives an experimental drug to fight cancer, the other a placebo. After 2 years, the spread of the cancer is measured. Is this an observational study or an experiment? And the answer, hopefully, is clear. This is an experiment. Okay, you can see that we've got two groups. We can see that a treatment is being applied to at least one group. The other group's getting the placebo, and then we're making an observation in hopes of determining that, or the effect of this drug on the spread of cancer. Okay, this is a good example of an experiment. You have to have those two groups. You have to have a treatment. Okay, hope this clears some things up for you. If you have questions about it, email me or post it on the discussion board.